Today we're going to work on unit rates and unit price, and this is going to tie right in with what we've been working on with ratios. First, though, we need to know what a rate actually is. A rate is a type of ratio, but it is specifically a ratio which has two different units. So, for example, if I know that if I have $20, I can buy 4 shirts, so it's $20 for 4 shirts, then that is a rate. And it's a rate because we have two different units. We have dollars that goes with the 20, and we have shirts that goes with the 4. So if I were writing this as a ratio, I could say that it's the ratio of dollars to shirts. And that ratio is a ratio of 20 to 4. So that is a rate, and again, it's a rate because we have two different units. We have dollars and shirts because our two numbers have different units that go with them. Now we could take it a little bit further and talk about a unit rate. A unit rate is a rate that has a denominator of 1. So, for example, I could take the rate we have of $20 for 4 shirts, and I could simplify that to a rate of $5 for 1 shirt, or $5 per shirt. So while both of those are rates, this one is a unit rate. And what makes it a unit rate is that one of our numbers that's part of that is 1. And so that's why it's called a unit rate. And we typically would not necessarily say it's $5 for 1 shirt. We would say $5 per shirt. Now think about the word per. You need to remember that the word per means for 1. And sometimes we might, see it in a different context, and it might mean in 1 or each 1 or something along those lines. But it's going to mean something along those lines. So a unit rate, again, means I want to know how much for 1. Or how many for 1, something along those lines. So let's look at some examples. So our first example, if it's $75 for 5 pairs of shorts, then we want to know what is the unit rate that describes that situation. So I'm going to show you a way to think about this that you might not have thought about it before. I'm going to use what's called a bridge map. And a bridge map looks like this. And the purpose of a bridge map is to be able to compare things and to show relationships. Well, that's exactly what ratios are. They're a comparison of quantities. They show the relationship between two things. And so the line that's here in the middle is our per. That means that's where we say it's the whatever's on top per whatever's on the bottom. So when we look at this, we're going to put our two things that are being compared. Our two things that are being compared are the amount of money and the pairs of shorts. So that means our units. So that's what's going to go in our first two top and bottom sections. Now, when we set up a bridge map, the first 2 sections of it are what we know. And the last section of it is what we want to know. So what we know is that it is $75 for 5 pairs of shorts. And what we want to know is what would be the cost for 1 pair of shorts. Now we're in middle school now, so we don't really use a question mark, although that's what it means. It means how much for 1. Instead, the way we would typically write that in middle school is we would write that as a variable. So you could use X, Y, Z, R, M, S. It doesn't particularly matter. I'm in the habit usually of using X, but you could use other letters there. And so our rate, we want to know how much or how many dollars for 1 pair. Now, you might be going, what in the world is this? But you might realize once you start looking at this that this looks pretty familiar. That is what we've been talking about when we're talking about solving proportions. You have two ratios that have to be equal to one another, and we have learned how to solve a proportion. So looking at that, pull that proportion off of that bridge map. So it's a ratio of 75 to 5 equals x to 1. And when I do that, remember how we solve something like this. We solve this by cross multiplying and then dividing, because that uses what we know about cross products. So 1 times 75 divided by our leftover number, which is the 5. Remember, we multiply the two numbers that are diagonal and we divide by the number that's left over, and that gives us the value of our missing number. And if I work that out, 1 times 75 is 75. 75 divided by 5 is 15. So we get 15 equals x, or x equals 15. So what that means is our unit rate is $15 per pair. Now, I know you probably could have done that without the bridge map, but there's a reason I'm teaching it to you that way. We're going to use that bridge map, that structure, for solving lots of different kinds of problems. And what it does is it helps us really organize our thinking and really look for the relationships between the things that we are comparing or writing rates about. All right, let's look at another example. So here's another example. We have 6 gallons of gas, and we're going to use it to travel 192 miles. When you look at this, my two units, my two things that are being compared, are my gallons and my miles. So when I set this up, I could say, well, I need 6 gallons to travel 192 miles. Notice if I'm going to put gallons on top, then the 6 has to go on top because it's a number of gallons. And if I put miles on the bottom, then the 192 has to go on the bottom because it's a number of miles. And you might be saying, well, how do I know which one has to go on the top and which one has to go on the bottom? Well, let's figure that out. If we did it the other way, we could say, if I put miles on top, I could say, well, I'm going to travel 192 miles on 6 gallons of gas. Now, technically, you could solve this problem either of these ways. We're going to solve both of them, and we're going to think about then which one actually makes more sense, even though both would be correct. So for the first example that's done in black, I can look at it and say, well, if I'm setting this up as a unit rate, then I want to know how many gallons for 1 mile. And so I can solve that by doing 1 times 6, I multiply the numbers that are diagonal, and then divide by the number that's left, divided by 192. 1 times 6 is 6, divided by 192. If I work that out, I'm going to get this answer. I might also get this answer if I get it as a fraction. If I solved it using the other bridge map, I would say, well, I can travel 192 miles on 6 gallons of gas. How many miles can I travel on 1 gallon of gas? And to work that out, I'm going to have to cross multiply and then divide. So multiply the two numbers that are diagonal, 192 times 1, and divide by the number that's left over. So divided by 6 gives me my missing number. If I work that out, I'm going to get that x equals 32. Now, there's a relationship here between these answers, and you can see that relationship particularly if you look at this and you look at this. Notice that when you look at those two answers, we could think of the whole number 32 as 32 over 1. So notice that the other answer has the same numbers, just switched. That shouldn't surprise you, because if you look at the units are the same, just switched. So that shouldn't really surprise you. But that brings us then to which one of those is the better answer? Well, I would suggest, and I think most people would agree, that the better answer is the 32, because then you can write it as 32, and you write your units in the order they're written from top to bottom. 32 miles per gallon. And that really is the easiest way to, that's probably the better way to do this, because it's easier to understand. Because the other way you would write it is you could technically write that it is 1/32 of a gallon per mile. But for most people, that's just much harder to understand than if we said it's 32 miles per gallon. Even though both rates really are for the same situation and they're both correct, it's going to make more sense for most people to say 32 miles per gallon. So here's the bottom line. How do you know which number to put on top? Well, the answer is you always put the bigger one on top. The only exception is if you're dealing with money, because when you're dealing with money, you're finding a unit price, and so money should always go on top. Let me say that again. When you're deciding what goes on top, always pick the bigger number and the unit that goes with it, unless there's money. Then money always goes on top. All right. So looking at our next example, we're going to type 144 words in 3 minutes, and we want to know what unit rate that shows. So it's already a rate because it's comparing two things with two different units, but we want to find the unit rate. So the two things that are being compared, 144 is our bigger number, so we're going to put it on top. So 144 words in 3 minutes. Now, what we're wanting to figure out then is how many words in 1 minute. And we can solve this using our cross multiply and then divide. So 1 times 144 divided by 3. So we divide by the number that's left, and that gives us the value of our variable. And when we do that, we're going to get x equals 48. So 144 words typed in 3 minutes really means 48 words per minute. And again, I know what order to put that in because the line right here means per. And so I write this as, I read it from top to bottom, words per minute. All right, we have one more example. And this example has money in it. So remember what I said, when we do our bridge map, we're always going to put money on top. So it's $2.69, and that's measured in dollars, for 20 ounces is how we're going to set this up. And then what we want to know is how much money for 1 ounce. And we can solve this using the cross multiply and then divide. So we're going to multiply 1 times $2.69 divided by 20. And that's going to give us the value of our variable. So that's what that problem is going to look like. 1 times $2.69 divided by 20. And when I solve that, numerically speaking, I'm going to get this answer, 0.1345, or in other words, 1,345 ten-thousandths. Now, this is a money answer. So we want to know the amount of money or the cost per ounce. Money, if you think about it, money always has to be written. If you're going to have something after the decimal, it always has to have 2 places after the decimal. We can't just move the decimal because if we move the decimal, we're changing the value of the answer. So what we have to do is say, well, I'm only going to look at the first 2 digits after the decimal. I'm only going to include that. And that's going to be my answer unless I look at this digit directly after it. Is a 4 big enough to make it go up? And it's not. So our answer then is going to be 13 cents per ounce. Our pancake mix is 13 cents per ounce. All right, now let's apply this to some problem solving. This first one's pretty straightforward. Maria pays $60 for 5 music lessons. What is the cost per lesson? So when we look at this, the first sentence tells us what we know. So that's going to be the first 2 parts of our bridge map. What we know is it's $60, so $60 for 5 lessons. And then the question says, what is the cost per lesson? Remember, the word per means for 1. So remember, the question goes in our last section of our bridge map. So what is the cost per lesson? So the thing I want to know is how much money. The thing I know is for 1 lesson. So there's now my bridge map completely filled out, and we're ready to solve it. We can cross multiply and then divide. 1 times 60 and then divide by 5. And that's going to give us our missing number. And our missing number, if we work that out, ends up being 12. So what that means is the cost is $12 per lesson. And remember, the way I got that $12 per lesson, the way that I knew that it was dollars per lesson, is because I looked over here at this section. And remember, the line means per. So when I read it top to bottom, it's dollars per lesson. Okay, let's look at just a few more. For my next one, you can type 45 words per minute. If you type for 5 minutes, how many words will you type? Pause for a moment and see if you can set up a bridge map for solving this one. All right, so probably a lot of you did this. And if you did that, you are incorrect. And you are incorrect for a few things should have told you that you were incorrect. First, if you cross multiplied and then divided, you got 9. And 9 words in 5 minutes doesn't really make sense. But second of all, if you go back and look at the problem, this doesn't work because the first sentence tells us what we want to know, or what we know rather. You can type 45 words per minute. That means 45 words in 1 minute. Well, look at what you wrote. You said you could do 45 words in 5 minutes, but that is not what the problem says. If you did this correctly, what you should have written is what the problem says. So the first sentence tells us you can type 45 words in 1 minute. And then the question part of it is, if you type for 5 minutes, how many words will you type? So I'm going to type for 5 minutes, and I want to know how many words. So that's the bridge map you really should have set up. If we cross multiply and then divide, we're going to do 5 times 45, and then we're going to divide by 1. And that's going to equal 225. So my answer is going to be 225. Specifically, it says, if you type for 5 minutes, how many words will you type? Our answer is 225 words. All right, let's look at one last problem. This one says, Alec runs at a rate of 5 miles per hour. If he runs 20 miles, how long will it take him at that rate? So take a minute, see how you would set it up, see what you think. Pause while you're doing that, and then check and see if you were correct. All right, so when we look at this, let's look at what we know first. Alec runs at a rate of 5 miles per hour. So we're comparing miles and hours, and what we know is Alec runs at a rate of 5 miles per hour. That means in 1. So 5 miles in 1 hour. If he runs 20 miles, how long will it take him at that rate? That's what we want to know. So if he runs 20 miles, then how long? So 20 has to go on the top because it's a number of miles, and what we're looking for is hours. So that has to go on the bottom. And when I solve this, I'm going to cross multiply and then divide. Remember, when we cross multiply, we're cross multiplying the two numbers that are diagonal from one another. So we're going to do 1 times 20, and then we're going to divide by the number that's left, which in this case is 5. And that gives us our missing number. So when I solve this, 1 times 20 is 20, divided by 5 is 4. So my missing number is 4. So if he runs 20 miles, how long will it take him at that rate? It will take him 4 hours. All right, I actually do want to look at one last scenario just for a moment to explain why we use this sort of thing. So it takes Matthew 5 hours to get to his grandmother's house, which is 270 miles away. It takes Jared 4 5/10 hours to get to his grandmother's house, which is 234 miles away. Who is traveling faster, and how do you know? So what we're looking for here is we're looking for a rate of speed. And if you think about it, speed is measured when we're driving. Speed is measured in miles per hour. So that's what we want to know, is the number of miles per hour. That's what we want to be able to compare. So what we have to do is find the number of miles per hour for each of them, and then we can compare them. So when we look at this, we're going to have Matthew, and his speed is measured in miles per hour. And then we're going to do the same thing for Jared. And we're going to compare the number of miles per hour. So for Matthew, it says it takes Matthew 5 hours to get to his grandmother's house, which is 270 miles away. So what we know is Matthew can travel 270 miles in 5 hours. What we want to know is how fast was he going, so how many miles in 1 hour. For Jared, it takes 4 5/10 hours to get to his grandmother's house. So it takes 4 5/10 hours, and that is 234 miles away. So we would say it's 234 miles in 4 5/10 hours. Now, the reason we have to do something with this, we can't just compare them the way they are. What we have to do is find out how many miles per hour, how many miles in 1 hour for each of them, because then we can compare their speeds. Because if they're not going the same distance and they're not going the same number of hours, then we really don't know for sure who was going faster until we find out each of their speeds. So for Matthew, we're going to cross multiply 1 times 270 divided by 5. So 1 times 270 divided by 5. And when we do that, we're going to get 54. So that means Matthew was traveling at a rate of 54 miles per hour. You might have seen MPH before, to stand for miles per hour. He was traveling 54 miles per hour. While Jared was traveling at 1 times 234 divided by 4 5/10. And that gives me my missing number. And when I solve that, I'm going to get 52. So what that means is Jared was going 52 miles per hour. So when we want to know who is going faster, we would have to say Matthew is going faster. And the reason we know he's going faster is because his speed is 54 miles per hour, while Jared's speed is only 52 miles per hour. So that's a way we can use unit rates to answer questions as well. We can compare unit rates. All right, so the reason we worked on this really with the bridge maps is because you're going to need this structure as we move further into ratios and proportions. So as you work with unit rates, please, please, please do set them up using bridge maps. I know it might seem like it's a little bit of extra work, but it helps to organize your thinking, and it's going to help when we get into other kinds of problems that deal with ratios and proportions as well.